Fisheries and Oceans Canada, or DFO, is researching new and innovative approaches that support the sustainable development of this country's aquaculture industry. Dr. Sean Robinson at St. Andrews Biological Station, New Brunswick, and Dr. Chris Pierce at the Pacific Biological Station in Nanaimo, BC, are DFO scientists involved in this research. They've been investigating various aspects of integrated multi-trophic aquaculture, or IMTA, as a new model of aquatic food production based on the concept of recycling. Robinson's work on IMTA began in collaboration with University of New Brunswick professor Dr. Thierry Chopin. It soon involved industry partners, research institutions, and universities from coast to coast. But what exactly is IMTA?
IMTA is a reasonably complicated way of just saying mixed farming. It involves the culture of a number of different species together, but not just randomly chosen. Each species basically has a function and a relationship to the other one.
Usually the main species is some sort of fed finfish species like salmon or sablefish. Then you would have plants like kelps that would take up the dissolved inorganic nutrients. You would have filter feeders like mussels, clams, cockles, oysters that would take up the fine particulate material. And then you would have the deposit feeding species like cucumbers, sea urchins, worms that would be directly underneath the farm that would take up the larger particulate organic material.
Much research has already been done on the seaweeds and filter feeders of the IMTA model. However, researchers are now turning their attention to the deposit feeder species and their potential for extracting fish waste and excess feed pellets.
And that's the important group for the environmental side of things, because that's where most of the organics are that are hitting the bottom, which are causing the eutrophication or the nutrient enrichment of the bottom sediments. Mostly in the zone just within the lease of the aquaculture cage, but those are the ones we want to try and capture. And that's where these new species are coming in. So one of the species that we've been focusing on as having a reasonable amount of potential as one of these extractive species in the benthic component are sea cucumbers.
To determine how effectively various deposit feeder species can recycle fish waste within an IMTA system, research projects were conducted by master's students on both east and west coasts through the auspices of the Canadian IMTA network. Under Dr. Robinson's supervision, master's student Emily Nelson recently completed her studies of the northern sea cucumber at the St. Andrews Biological Station.
I just finished my research and it's really promising. One of the things we've been finding is that these sea cucumbers are capable of consuming the aquaculture waste. We were able to show that both in a laboratory setting and when they're feeding directly at an aquaculture site. And also we were able to show that they're really efficient at absorbing organic material. So they're absorbing between 79 and 85% of the organic material in every food that they're consuming. So in terms of IMTA, they're going to be very efficient and they're showing a lot of potential. So there's a lot of interest.
At the Pacific Biological Station and under the supervision of Dr. Chris Pierce, grad student Lindsay Orr studied a number of West Coast deposit feeders, including the California sea cucumber.
So these species will shovel the sediments into their mouth using their radial tentacles and digest the food and absorb the food. And in my studies, I did find that they do ingest the sablefish waste and they will absorb organic material from the sablefish waste. So this is promising because these are candidate species that we're hoping to co-culture with sablefish in British Columbia.
IMTA in Canada is still in the developmental stage, but field trials are showing promising results.
In the sea cucumber cages underneath the farm, the amount of organic material was reduced in relation to the amount of organic material in the control cages, suggesting that the cucumbers were taking up the organic material.
But IMTA deposit feeders are not only chosen for their ability to recycle the nutrients and wastes in and around fish farms. They are also selected for their market value.
One of the features of IMTA as a principle is that it's not just about production and it's not just about the environmental sensitivity or the greenness of the approach. I mean, it has all that. but it's also about the economics behind it. And one of the ways of helping industry involve is to give them a solution that ultimately doesn't cost them money, but actually adds to their bottom line at the end of the year.
So there's one company on the west coast of Canada that's currently involved in IMTA commercially, and that is Sea Vision Group Incorporated, that's headed up by Dr. Stephen Cross.
Basically, the collaboration that we have had with DFO and continue to share is largely through their scientists and through a shared graduate student or 2 or 3. So we actually collaborate in design of experiments. One of the benefits of doing a multi-species model is that you're capitalizing on the ability of the animals that you select to serve in an ecological role. But at the same time, if you look at it from a business sense, for every scoop of feed that you throw into the cages, you are getting more for your bang for your buck. I mean, most of it goes into the fish. That which is released to the environment is intercepted, extracted, and converted into additional species. So we're actually getting more valued product for every scoop of feed.
And the market value of species such as the California red sea cucumber is increasingly significant, especially in Asian markets.
We are tapping into the market on the other side of the Pacific, and we won't be able to produce enough to really satisfy that kind of a marketplace.
On the east coast of Canada, in New Brunswick, Cook Aquaculture is a key industry leader in collaborative IMTA research. They are already using the results of this research on a commercial scale to produce and market IMTA products in Canada. So, what does the future hold for this approach? Will IMTA change the shape of the aquaculture industry?
I think you will see more and more commercial scale farms moving towards IMTA in the future. It's not only ecosystem friendly, but you're also economically advantaged by having these numerous species on site that are marketable.
Fisheries and Oceans Canada is continuing to study integrated multi-trophic aquaculture as one possible solution for a balanced approach to ecosystem management, one that offers potential benefits for growers, the environment, and for Canadians.